And welcome back to the Turd Ferg Network. All right, today's video is on the introduction to the power rule homework assignment that you had. I think there was 18 problems on there, and most of these should have been really easy. You should have went through them very fast. We've already talked about how to do power rule problems. All you're doing is taking the exponent, multiplying, subtracting one from that exponent. I just picked 4 off of it to go through and do. These shouldn't have been too hard for you, but let's see if we can apply this power rule to these formulas. And the only thing you're supposed to do is just take the first derivative on each one of these. I don't think they ask you to do second derivatives on here. All right, so let's go ahead and do number 4 up here. Let's do it first. Y equals negative 10. So we got a function of y equals negative 10 x squared in this problem. And all we're going to do is apply the power rule. So all we're going to do is take the 2 and we're going to multiply this problem by 2. So this is going to become negative 20. And then that x, we're going to go back and subtract 1 from our exponent. So when we subtract 2 minus 1, it just leaves us with 1. So it's just x. So y prime is, so our derivative is y prime equals negative 20x. All right, well, that's easy enough. How else could we have done this problem? Well, we could also go back and take a second derivative, just the derivative of your derivative. It didn't ask you to, but we could. Well, that's also going to be pretty easy. We're going to multiply the exponent, and just remember the exponent's not there, but it's really a 1. So if we multiply by 1, well, that's going to be pretty easy. That's going to be negative 20. And then we come back up here, and well, we subtract 1. And if we subtract 1, then, well, nothing. So anyway, so that's the end of that problem. And we'll go back and clean up these. I don't like leaving them kind of, oh, I cleaned up too much. Let's, I can put it back. So there we go. Matter of fact, let's get rid of that whole one. There, much better looking. Now, a good question might be at this point, what if you took one more derivative? What if you took the derivative of negative 20? Well, that's a constant. So if you've already forgotten, the derivative of a constant is 0, because a constant has no slope if you were looking at a graph of it. So if there's no slope, well then, 0. So come back, the derivative of that constant would be 0. So we went through and kind of did every derivative in that one. Let's go through these other examples real quick and make sure you kind of know what you're doing. Looks like I'm still holding an eraser there. I hope not. So anyway, all right, so let's go and do this one. What might throw you off here would simply be this x cubed over 3. Well, that's the same as 1/3, which still should not be a problem. We could rewrite it as a third, but it's not necessary. We're going to treat the problem the same. All you do is do each of the parts. So this would be 3 times, so we'll write it out up here. This would be 3, that would be 3 times x cubed over 3. And then we would also completely separate, let's see, this other piece. That would be 1. So this would basically be 1 times negative x. Well, 1 times negative x would just be negative 1. And if you look, subtracting 1 from this, it's nothing, so it's just negative 1. And now if we look, 3 times x cubed, oops, I forgot something. I forgot to subtract 1 from that 3, which means reality of this is, this should be a 2. So subtract 1, multiply, and subtract 1. So we end up with the 3's cancel, so x squared minus 1. So if you didn't get that in class, all you do, even if you had, I'm just going to write off to the side number 10. This is number 10 out of your homework. And number 10 was like 1 minus x squared minus x cubed. And the cool thing about that is you just take the derivative of each piece. So this is derivative what you're doing is you're taking the derivative of 1, you're taking the derivative of negative x, the derivative of negative x squared, and the, run out of room, derivative of negative x cubed. And that's all you've got to do when you've got something like that. So this would be a derivative, that's 0. Derivative of negative x is negative 1. The next one would be negative 2x. And then the last one would be negative 3x squared. So this would be your derivative. All right. So what else on your homework? Well, I skipped to number 16. Not really 16, 18. I was just wondering what you were going to do when you had this. And later on, we've got another rule we could use to actually do this problem. We could do a product rule if we wanted to. Both these could be product rules. The thing is, I wouldn't even do a product rule of these because they're both very easy. What should you be thinking of right now? Distribution. So all you've got to do is multiply that across. X to the 5. Remember, when you multiply exponents, you add. So multiply the exponents you add minus x squared. Now you can go back and take your derivatives. So this would be 5x to the 4th minus 2x. And I'm gonna write this one as dy dx like that. Could we take another derivative? So could we go d squared y dx squared? Could we go this way? Well, yeah, that wouldn't be too hard. We can take a second derivative just using different notation. It would be 20x. So we multiply by 4, and then we subtract 1. Well, that leaves us with 3. And then minus 2x just becomes minus 2. Because all you're doing is multiplying by 1 and subtracting 1, which gets rid of the x when you subtract 1. So that'd be the second derivative. At this point, you should already be beating me. Yes, I want to extend the page. You should be beating me to this last one. Once again, all we need to do on this one, FOIL this thing. So that would be 6x squared plus 15x minus 2x minus 5. So 6x squared plus 13x, hopefully that's not bad luck, minus 5. So here is our function. So now let's see if we can take the derivative of this function. Well, that would be 2 times 6 is 12. Subtract 1, just be 12x. 1 times 13 is 13. Subtract 1 gets rid of it. And the derivative of negative 5 is 0. So our answer is y prime. And we could take a second derivative. Y prime prime would be, well, let's just see. It'd just be 12. Derivative of 13 is 0. What about a y prime prime prime? If we want to go one more, well, once again, we'd be at 0 in this problem. All right, and that should pretty much wrap you up for the homework. So thanks for watching. Bye.